So one of the things that characterizes mass production is the use of large machines that are efficient in churning out high volumes of the same part or similar parts, similar products. One of the things Toyota set out to do when it was developing its car building business was Toyota recognized that increasingly customers are seeking variety. They want multiple colors, multiple options, engine sizes, levels of trim. And that represented the way markets around the world have moved decade after decade as people want something different. They want to personalize their purchase. And so a major constraint with mass production is the ability to change over the line, change over machines to produce batches of one, which is the ideal in lean thinking. And many times in the Ford and General Motors factories of the 60s and 70s, you were talking of multiple hour changeovers, 7, 8, 10-hour changeovers for a press. And so what do you do in that situation? You avoid changing over. Well, I've got the machine running, I'll make more than I need, I'll hold the stock, and then I'll change over when I need to. Of course, that drives up inventory, and then that hides problems and all the waste that entails through overproduction. Toyota turned that on its head with smaller machines and the ability to reduce changeovers to less than 10 minutes. Hence this term, SMED. Bit of an ugly term, but it's referring to single minute exchange of dies, exchange of tooling. And if you can change tools quickly, it doesn't matter what sequence we make the product in. We can be agile and flexible to match the demand of the customer, not just in volume, but in variety. Shigeo Shingo, one of the pioneers of lean thinking within Toyota, led the development of SMED, single minute exchange of dies. There's a famous story of him working with a press shop in the main Toyota facility in Japan, which had a 4-hour changeover. It's a 1,000-ton press. And he challenged the team there to reduce the changeover time in a dramatic fashion. And he gave them some training. He was teaching them about internal versus external components of the changeover. I'll say more about that later. He left them to it for a couple of months and came back. And when he came back, they said, Mr. Shingo, we've reduced the changeover time from 4 hours to 90 minutes. What did Mr. Shingo say? He said, well done, please try again. And he gave them a little bit more coaching because he knew significant progress had been made, but there was much more to come. Same cycle, he left them to it for a couple of months. He came back and they said, Mr. Shingo, we've got it down to 30 minutes. And what did he say? He said again, well done team, please try again. This is an example of Mr. Shingo following that principle, pursue perfection. He was pleased and recognized the progress, but he knew that there was more to come. And he was stretching the team, challenging the team to go further, to keep going, continuous improvement. And eventually they got it down to much less than 10 minutes. So this was a challenge to the team using structured methodology, which we're about to explain here. Also some creativity and cross-functional thinking, welcoming different perspectives. So the methodology of single minute exchange of dies was born and was documented and became to be known around the world. And of course it impacts many industries. You think about the time to set your laptop up, to start it up in the morning when you want to get going with your work. You think about the time to turn an aircraft around at the gate. Because an airline is only earning money when the aircraft's in the air. So that's a lost time when it's on the ground. If you think about a restaurant that needs to change around tables quickly to enable the next guests to sit at the table. So the principle applies in many industries. Let's look a little more detail at the way SMED works. First of all, the definition of changeover time. Well, to be consistent, we define the changeover time as we start the clock at completion of the last good part of the existing batch that we're running. So once that is delivered, or once that's complete, we start the clock. And we keep the clock running until we've achieved completion of the first good part of the next batch. So that elapsed time is the lost time to production. That's the changeover time. And this can still be, in many industries, several hours if you've got significant cleaning involved, adjustments, paperwork, quality control, approvals. This can still take many hours in many industries. So how do you set about reducing the time? Well, let's look at what typically happens in a changeover time. Why is it taking so long? What are some of the activities that are taking place? So here's the before condition, the current state, if you will. And I'm manufacturing product A. That's the old batch, if you like. And I stop production. So I've now completed the last part of batch A. And I start my setup time, and here's the elapsed time where for batch B I complete the first good part for the new batch and then continue to run production. So here's my changeover time. It might be multiple hours. Now what's happening in this time? It could be a number of things. I might be, for example, fetching tooling, organizing the correct tooling. It could be raw materials that need to be put in place. I need to find the instructions, make sure I've got the work instructions ready. There might be batch paperwork to get signed off, to get ready to find. You can see how the time can be quickly filled here. There might be on the machine side, on the line side, to do with, there might be some cleaning. There might be some cleaning operations to be done. There may be measurements and settings and calibrations to be done. There might be some trial runs and adjustments that might be important. And there might be some after-process adjustments as well. So we're trying to get production up and running, and there are some further refinements and adjustments. And within all of this, we're actually changing the tool. We're actually setting the machine ready and the line ready for the new batch. So you can see a whole combination of activity to do with the machine, to do with tooling, materials, paperwork, and so on that are necessary. And it might well be that all of these activities are happening in the current state while the machine is down. So let's look now at the future state, a different way of organizing where we can minimize this changeover time. So now let's look at what's possible were we to organize this differently. First of all, fetching the tools. Well, surely that can be done while the machine is still running. So we'll place that as an activity that's conducted in parallel to the batch A still being produced. We could be preparing the materials, getting those line side. So that's all done up front. Similarly, the finding the instructions, and maybe even some of the cleaning can be either eliminated, it can be reduced, or could be done while the machine is running. So maybe some of this, I'll just put it, most of it is done while the machine is running, and minimize what is done while the machine is stopped here. Clearly, changing the tool can only be done while the machine is stopped. So I'm going to place that in here. Maybe some of the cleaning could happen in parallel. Let's see, that's possible. Again, batch paperwork, that can all be done while the machine is still running. Now, when it comes to Settings and calibrations and adjustments, that's where some of the engineering change and solutions can help to eliminate or reduce these. We certainly don't want to, we want to avoid and eliminate after process adjustments. So let's find a ways of simplifying the activity, standardizing activity, and eliminating that activity. And one of the things is that, often this still is continuing after we've started production, so it can actually take us quite a while to ramp up to standard pace because we're still tinkering and fettling to get the machine to run at standard speed. So these measurements, settings and calibration, well, why can't we design the fixtures and tooling so that these are done offline, if at all, that these are done on jigs and fixtures off the line while, again, the machine is still running. And again, trial runs and adjustments, we'd want to minimize that activity, if not eliminate. And so what we're able to do is make a radical reduction in the lost time due to changeover by applying a number of lean techniques. Firstly, by creating this shift from internal activity to external activity while the machine is running, and then standardizing and simplifying so that the activities we still do need to do are reduced in time or eliminated completely. And that's how SMED works. A number of different lean concepts and tools can apply to reducing changeover time. The main concept that Shingo brought with his SMED method was this notion of separating internal from external activities so that we could minimize the downtime associated with those activities which can only be done when the machine is stopped. And then making sure that these activities are done made as simple as possible, without need for adjustments, we can be sure that things are right first time. So how do you go about this? What are the steps involved in running a SMED changeover time reduction exercise? Well, first of all, like with many of these activities, create a team, cross-functional team of subject matter experts and maybe even also fresh perspectives, fresh eyes. You'd want to determine the current conditions. In other words, understand the current state, collecting data and visualizing the timeline that is involved in a full changeover. To directly observe and record what is happening today. Very often it's helpful, many organizations do this, is video. Video the activity, maybe use more than one camera. Watch the setter, the operator, what are they doing? Watch the machine, how much activity is actually taking place on the machine or the line versus off the lines, in an office maybe, in a lab maybe. And then start to analyze and break down what are these activities, which is internal, which could be external, where's the waste? Are we seeing different forms of the 7 wastes present in the changeover activity? And then we can start thinking about converting internal to external. We can start streamlining. We can start mistake proofing. We can use 5S thinking to organize the workplace, to minimize motion so that everything's in its right place, and we can be really efficient. And then start thinking about, can we automate any of this? Can we redesign jigs and tools and fixtures and use location pins to eliminate adjustments? And then finally start to standardize, to train, to document the new standard, the new method, and ensure that it's being followed in a consistent manner. And then perhaps there's continuous improvement to follow. But those are the essential steps to be working through in a SMED exercise. And within that, you might have designated roles. The person is designated to record, each step and record the observations that are associated with each step and make sure that we document which of the 7 wastes are present. Someone to watch the time, to record the time and associate time to different activities. Someone is responsible for the videoing, making sure we capture the key points and make it available to view. And then others who are there to observe, to have conversations with those doing the work, and to make notes on where they see opportunities for improvement. And so documenting this could take a number of forms. You could imagine a timeline with the time as a scale with the different activities, like similar to a process map laid out horizontally, showing the sequence of activities, which activities are in sequence, which are maybe in parallel, which might be another improvement opportunity to reduce the cycle time. This table here on this chart shows a breakdown of the different elements where there's opportunity to eliminate or remove activities or shift from internal to external or just reduce the time it takes by being more efficient. And finally, having simplified the operation and being better organized, and I do think, typically 80% of the benefit comes through organization and simplification, and then the last 20% or so can come from better tooling and technology and automation, by spending money, in other words, on capital to get that further improvement. But I would recommend you do that after resolving some of the organizational and process opportunities that you're identifying. So that in a nutshell is the SMED methodology, single minute exchange of dies. Really important because not only does it reduce the time taken for changeovers, what that does is creates capacity, but also flexibility to enable your business to adjust and schedule work in line with the demand of your customers, minimizing inventory and minimizing other forms of waste in your facility.